Okay, we're going to talk about indistinguishable objects and permutations. They have a special formula, which is n factorial over p factorial divided by p factorial times q factorial. So, for example, if p objects are indistinguishable, and another q of the objects are indistinguishable, then the number of distinguishable linear permutation of n objects is this formula. So we're going to really look at one word real quick, and so I can tell you what I'm talking about. If we arrange this word, usually what we'd say is how many different ways to arrange this word. So basically what we did before on the counting principle, there's 3 of them, right? And we'd go 3 times 2 times 1, which would give you 6 different ways. But in this case, we have 2 identical letters, which is M, the M. So if I try to write all this out, my first way to arrange the word is M-O-M. My next way would be O-M-M. And my next way would be M-M-O. There's no other way to have distinguishable objects arranged. So this answer is actually incorrect. So the formula we're going to use is that we have identical M's here. So what you do is you take the total number of objects in objects and divide it by our identical objects. So we have a total of 3 factorial over, and my distinguishable objects is 2. And if you write this out, this would be 3 times 2 times 1 over 2 times 1. The 2's cancel, and so we have 3, which we can see right here. There's 1, 2, 3 ways to arrange this word, because we don't have 6 anymore because the M's are identical. So let's look at a couple word problems and we'll do some more words. We have 5 people lined up for a photo, so that's a total of 5 people. But 2 sets of identical twins that are dressed alike. And so the question is, how many possible lineups would be possible that are distinguishable? And the key word is distinguishable and identical. So especially identical. If you see that word identical or see identical, you know you're going to have to use this formula. So we have 2 sets of identical twins. That'd be 2 factorial over 2 factorial. And when you work that out, you get 30. All right? 30 ways so that they're distinguishable. Now, here's another word problem. We have 3 identical pin sets and 5 identical watches. And they want to be given to 8, there's a word left out, 8 graduates. So the total number of graduates is 8. And we have 3 identical pin sets and 5 identical watches. And when you multiply that out, we get 56. Okay. Next, we're just going to do some words. We already did mom, so let's do Monday. We have 1, 2, 3, 4, 5, 6 identical, or 6 objects total, 6 letters in this case, but all of them are distinguishable. So we're not going to divide, and our total is just 720. Okay, the next word we have is stereo. We have a total of 6 again, but our E's are identical. So we're going to divide by 2 factorial, and your number is going to be 360. And we can do a few more. Let's do the word Canada. So we have a total of 6 again. But our distinguishable objects, we have 3 A's, and that's it. So we divide by 3 factorial, and you get 120 ways. These are all ways. Let's try 3 more. We have Ileana. I'll make this capital so it's not confusing. All right, so our total again is 6 factorial, but we have 3 i's. So we divide by 3 factorial. We also have 2 l's, so that's over 2 factorial. This is your p factorial and q factorial. And our total would be 60. Another word we have is annually. A-N-N-U-A-L-L-Y. So this is 1, 2, 3, 4, 5, 6, 7, 8 total. However, we have how many L's? 2 L's. We have 2 N's. And we have 2 A's. So when you divide that out, you get 5,040 ways. And the last word I have is members. And then I can't spell. So let's do it again. Members. So we have a total of 7 objects or 7 letters. I have 2 E's. And I have 2 M's. When you multiply that out, you get 1,260 ways. And I think a good way to remember this is to write out your name. And do your name, and you'll always remember it. So my name is, you should make all this caps because you want them to be distinguishable. I'm just going to make all my letters small. Here's my name. How many ways can I arrange my name? So I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 factorial. I have 2 S's. Let me do that in green. And I have 1, 2, 3 A's. And that would be your, do I have anything else? No. And then just multiply that out, get your amount. I don't have my calculator with me, but so you try. Do your name. If you do your name, you'll remember this. And what's the key? The key word is identical. Okay, the next video I'm going to do is on permutations in general. And we're going to do a few word problems with permutations. And then after that, I'm going to talk about mirror image permutations, like charm bracelets and keys on a chain, or keys on a ring. Thank you and have a nice day.